Hello, everyone. Today we start our webinar about from Data Phoenix, our charity webinar on which we raise money for the COLA, Ukraine project, which provide high-end equipment for our army. We raise money, we help them, and this webinar today we do together with Sarah and with Alona. She will talk us about Vertex AI pipeline infrastructure with Terraform. We will speak about how to manage AI infrastructure for machine learning model, how to deploy, how to automate pipelines. You can ask questions using Slander. The link is under the video. Also, you can join us to Zoom, and we can do discussion about after the presentation. Also, don't forget to donate if you like our webinars and you want to support Ukraine. So the link is under the video. Also, Alona for now located in Ukraine, and we hope we will not have some alarms and attack and during the webinars, but if we will have it, so maybe we will a little stop, then continue in sometimes when Alona change the location in a more safety place. Yeah, not forget donate, and I will give the microphone to Alona to present her topic.
Hi. Let me share the screen with presentation. Let me know if you see it.
Yeah.
Okay. So, hi. Thanks everyone for joining. I'm Alona Slestin, and I'm an ML engineer at Software. I was wondering how I could describe my passion in work, and I think that I love everything that needs to be automated. Anything that is still triggered or finished by hand. I think we all deserve to delegate the repetitive work on the machines, especially one that has to do with data. That's why today I would like to share with you one of the ways to automate it, Vertex AI Pipelines with Terraform infrastructure. Okay, let's start with agenda. What we are going to discuss today. We will start with a small intro. Then we will cover some general information about GCP Vertex AI and what it does, and discuss key features. After that, we will go through the simplified ML workflow and what it includes. And we will then learn key things about Terraform and finish with the most interesting part, use case about pipelines building. Okay, let's get into the business. Today, no one can argue that machine learning has found its way in all areas of human life, from social science to industrial enterprises. But the questions on how to properly organize the work of those ML models themselves are relevant as never before. This process includes several stages. An ML part of building forecasting pipeline, and DevOps, deploying infrastructure. In that view, I would like to present this talk about Vertex pipelines and infrastructure deployment with Terraform. And of course, I will add some examples of them. And enjoy the talk, and let's start. Nice to meet you, Vertex AI. This is a Google Cloud Platform service. It includes sets of tools for data scientists and machine learning engineers. You can see on the slide the UI with some of them. For example, Workbench notebooks or Vertex pipelines. What's the use of it? It helps to streamline ML workflow and access the AI world. It's targeted specifically at building, deploying, and managing machine learning models in the cloud. It can be used to train at scale, which is so important today, and host in the cloud. Let's now dive deeper into the Vertex. You're going to hear the word component quite a lot from me, and for that, I would like to give a definition for it right away. A pipeline component is a self-contained code that is responsible for one step in the pipeline. For example, data pre-processing, data transformation, model training, and so on. I will describe several features, but GCP Vertex AI includes also pre-trained APIs for vision, NLP, video, as well as data labeling service. You can see the full structure on this slide. Components of Vertex AI. Let's start with the workbench. Before building the final version of an ML model, data scientists do a lot of experimentation. And in this case, they can use Workbench, a cloud service based on Jupyter Lab, but managed by Google and scale. I think everyone involved in ML understands what I'm talking about. Continuing with one model, there is the Vertex AI Pipeline service. It helps to create end-to-end training of prediction pipelines with custom components based on Kubeflow. Actually, it really helps to automate an existing workflow. What about training service? This allows customized training with capability of different machine types to do training jobs, to enable distributed training, and to do a hyperparameter tuning jobs, and to accelerate with GPUs and TPUs. You can submit your input data for Vertex AI for training using one of built-in solutions. And if it doesn't fit your case, there is a possibility to train an application to run on Vertex AI. You can also build a custom container with your training application and its dependencies on Vertex to run on Vertex AI. And speaking of model registry, it's a central repository where you can manage the life cycle of your machine learning models. You can use it to store, monitor, and compare your model versions. But what is Terraform? Terraform is an open source infrastructure as code tool developed by HashiCorp. It's a software company from California. It's used primarily by DevOps teams to automate various infrastructure tasks. The provisioning of cloud resources, for instance, is one of the main use cases of Terraform. It can be used for different use cases, for example, multi-cloud deployment, application infrastructure deployment, scaling, monitoring tools, policy compliance and management, working with Kubernetes, and parallel environments. Okay, we already discussed key features of Vertex AI, but what about Terraform? Let's do it. Infrastructure as code. What does it mean? It's the process of managing and provisioning your resources. We use for it definition and configuration files, usually separated into different modules. Next, automatization. As I said, this tool helps to automate part of the DevOps work and get rid of the part of manually repeating the creation of the infrastructure. It's also important that Terraform scripts and models are reusable. It means that if you create a Terraform script with Vertex AI deployment, with all required Google Cloud Storage buckets, service accounts, YAML settings for current project, you can use it for any other project in future. Assuming all prerequisites are installed, of course. And finally, is the Terraform works only with GCP? No, it's compatible with any cloud with the help of providers. So whether you're working with GCP, Azure, Amazon, etc., you will be using different services, but the Terraform tool is multi-purpose for deploying your infrastructure. Given all these features, we can talk about the importance of Terraform for ML engineers. You can be sure that when you create a new project, it will consist of all necessary services and accesses. And you will be able to declare in structure model all necessary things. We figured out why Terraform is needed, but how to work with it and what steps does it include? First, you are starting with writing Terraform scripts. There are special guidelines and best practices for it. I would like to draw your attention to a few of them, but the full list of rules are available in the documentation and various articles. Terraform models must follow the standard model structure. A model is a container, multiple resources that are used together. You can use these models to create lightweight abstractions, so that you can describe your infrastructure in terms of its architecture rather than directly in terms of physical objects. Next. Reusable models are defined using all of the same configuration language concepts we use in root models. Most commonly, models use input variables to accept values from the calling model, output values to return results to the calling model, which it can then use to populate arguments elsewhere, and resources to define one or more infrastructure objects that the model will manage. And also, you should limit the use of custom scripts. Use custom scripts only when necessary. The state of resources created through scripts is not accounted for or managed by Terraform. And finally, I think it's one of the main things, put static files in a separate directory, or in case of running Terraform with Cloud Platform, as in our case, to a separate bucket with limited access. Let's move to Terraform plan. Terraform includes a plan step for all your resources. You can use it to understand how your potential infrastructure on GCP project will be deployed. We recommend you to not ignore this step, as the Terraform resources contain a lot of input parameters and settings. The Terraform plan will always show you the difference between your current infrastructure and the new one, including all these settings. And you can preview the actions Terraform will take to modify your existing projects and estimate costs. Moving forward to Terraform Apply. After you checked your potential infrastructure and ready to approve the deploy, you can use Terraform Apply stage. It executes the changes defined by your Terraform configuration to create, update, or destroy resources. And finishing with Terraform destroy. You use a destroy command only when you want to destroy all remote objects controlled by a particular Terraform configuration. I want to draw your attention to the fact that this step should be performed only when the infrastructure should be completely destroyed. We are not talking about deleting or changing specific resources, because this function is performed by the apply command. Besides, it's good practice to follow the rule. If you create an object or resource with Terraform using apply stage, you must delete it also with Terraform, but destroy or apply stage. Otherwise, next time you start Terraform, it will not be able to find some elements that was deployed in your infrastructure. It's necessary also to talk about simplified ML workflow before we will run into our use case. On this chart, you can see a simplified machine learning workflow. I think this is not new to many of you, and perhaps now you think that you can do everything using regular frameworks yourself. And while I'm discussing the topics of setting up pipelines, if everything can be done locally in notebooks, let's discuss this as we move to the cloud. A big part of it is covered by GCP Vertex AI. These stages are iterative. You may need to re-evaluate and go back to the previous step at any point in the process. Let's go through them and find the main characteristics. Starting with data ETL sourcing and preparing your data, and model initiating and training. Users can develop models in 2 steps using different tools, for example, BigQuery, Dataflow, Python, etc. And then include them into Vertex AI pipeline steps. Vertex provides the services you need to train and evaluate your model in the cloud. For example, a hyperparameter tuning job to optimize the training performance. Moving to model deployment. You can host your model in the cloud. Vertex AI provides tools to upload trained ML model to the cloud. In order to deploy your trained model on Vertex AI, you must save your trained model using the tools provided by your machine learning framework. This involves realizing the information that represents your training models into a file, and it you can deploy for prediction in the cloud. Next, sending inferences to your model. Vertex provides services that you need to request predictions from your model in the cloud. There are 2 ways of getting predictions: online or stream predictions and batch predictions. Talking about monitoring your prediction services, I think we all agree that keeping an eye on how the forecasts are being run is important. Vertex provides APIs to examine running jobs. In addition, various Google Cloud tools support the operation of your deployed models, such as cloud logging or cloud monitoring. And we're finishing with managing your models and versions. Vertex provides various interfaces for managing your models and versions, including a REST API, the G-Cloud command line tool, and Cloud Console. As you can see, even such a minimal workflow consists of using several Vertex AI services, and before you can use them, you need to enable it and set permissions. In our case, to launch Terraform to deploy infrastructure with all these services. And now, when you know some key points about Vertex AI and Terraform, we can talk about our use case. What data we are using for this example? It contains information about customers' demographic and their transactions in Middle East cinemas. And what we wanted to do. From a business stakeholder perspective, we want to increase the revenue through promotional campaigns. and a stable prediction solution is needed to be included in marketing offers. From data science perspective, we want to create a model that will forecast customer spends. From ML engineering perspective, we should have a fully automated training and prediction service with reporting and evaluation. And if we are talking about orchestration, we are going to automate ML part with Vertex AI and other GCP services, and on the other hand, to develop Terraform script to deploy our infrastructure. Let's continue with high-level overview of the architecture. As a DevOps pipeline service, we use Azure Pipelines. It deploys infrastructure pipeline, and when it's ready, it can compile and run MLOps pipeline. And I'm going to describe the selection of this toolset. Why Vertex AI? Firstly, there is opportunity to build forecasting model with no-code service after ML. And it helps to orchestrate a full lifecycle ML pipeline, including any custom step. For example, data preprocessing, hyperparameter tuning, model exceptions, etc. And also, we can generate batch predictions fast with automatically deployed model by AfterML. Next, why Terraform? Firstly, Terraform has a simple syntaxes if you already have an experience working with configuration files. It's also cloud agnostic. And finally, all services are managed, versioned, and easily reused. Thus, there is no need to repeat manual steps if you need to deploy such services again in another project, for example. And finishing with why Azure Pipelines. With this tool, we can quickly build and deploy mission-critical web applications at any scale. Here again, you need some experience writing such configuration pipelines. It helps to automate builds and deployments, for example, based on the full code changed or some text, and is fully integrated with GCP. This allows you to create a CI/CD pipeline and run various functions based on user inputs. Our next step is initial infrastructure setup discussion. Our starting point is Azure DevOps. This is our repository with demo data and scripts. Then, using the YAML script, we automatically deploy and start Azure pipelines when the new code was pushed, which will copy all Terraform scripts to the Google Cloud Storage bucket. GCP project, Google Cloud Storage bucket, and service account for accessing the GCP are included in the prerequisites that must be created in advance. Once Terraform scripts are available, we are going to manually start, plan, and apply the Terraform steps. You could ask why manually if we automate everything. Based on our experience working with Terraform, we can recommend not including these steps in the pipeline, for example, Azure pipelines, and do it by yourself to check everything and make sure that there are no problems. After that, our infrastructure is ready. It contains a stage Google Cloud Storage bucket to store intermediate files and input data. We use copying from repo as an example. In production, your pipeline code uses data from any data warehouse system, for example, BigQuery. Service account to run Vertex AI pipeline with all required permissions. Also, secret manager restore the credential of this service account. And finally, pub subtopic to trigger run of deployed cloud function to run Vertex AI pipeline. When infrastructure is ready, let's jump to compiling ML pipeline and run it. As in previous step, we start from Azure DevOps that launch Azure pipelines. It's another functionality of the same pipeline we used in previous step. It installs all required Python packages to compile the Kubeflow AI pipeline. Before Vertex AI pipelines can orchestrate your ML workflow, you must describe your workflow as a pipeline. ML pipelines are portable and scalable ML workflows that are based on containers and Google Cloud services. We create pipeline with the KFP-DSL package contains the domain-specific language. You can use it to define and interact with pipelines and components. After that, you can proceed to compile the pipeline into JSON format. The JSON file will include all the information for executing your pipeline on Vertex AI pipelines. Our Azure pipeline saved JSON file on our stage bucket. We created previously with Terraform, as you remember. Next, PubSub. It's a GCP service that ingests events for streaming. In our case, PubSub trigger enables a function to be called in response to PubSub messages. There is an alternative triggers. You can change it based on your tasks. For example, there are also cloud storage triggers. It runs if there are any changes in your Google Cloud Storage bucket. All these triggers are very flexible and you can modify it based on your business needs. Then we publish a message to previously deployed PubSub topic, which will trigger cloud function. It's one more Google Cloud Platform service. It allows us to use a serverless execution environment for building and connecting cloud services. With cloud functions, you write simple single-purpose function and then attach it to events emitted from your cloud infrastructure and services. In our case, we created with Terraform cloud function to launch Vertex AI job. And finally, let's see what is included into our Vertex AI pipeline. All components are custom, so you create them based on your task. And Kubeflow pipeline components are factory functions that create pipeline steps. Each component describes the inputs, outputs, and implementation of the component. We are starting with pre-processing data. Transform raw data from Google Cloud Storage using Python pre-processing model that you created before, and save intermediate data set back to the bucket. Then create manage data set. The HTML model requires a Vertex AI managed data set as input. It's one more GCP service. So we created from a pre-processed data artifact. Next, train model. Build an AutoML forecasting model and automatically deploy it to model register. Moving forward to evaluate model. Evaluation of the model based on the selected metric was done automatically by the AutoML job, and we extract the metrics at this stage. Talking about model acceptance. Before future use of the trained model, we need to make sure that the quality is acceptable for us using evaluation metric threshold. And the last step is batch prediction. generate prediction using the trained model in new Google Cloud Storage data. Usually, batch prediction job is included into separate pipeline, also in Google Cloud Store, also on Google Cloud Platform and Vertex AI. So today we discussed how we can orchestrate ML pipeline with GCP services and automate infrastructure deployment with Terraform. We are working on creating more and more interesting projects, developing ourselves and making a good job for our clients. And sure, we are waiting for the win of Ukraine in this difficult time. And I want to wish you happy holidays and thank you for this opportunity to present our findings. And we can jump into question session.
Okay, thank you, Elena. Maybe I will start and share our Slido. So if you have some questions, you can use link in the Slido and write the question on it. One moment. Yeah, so please write the question in the Slido. And my first question, you use for the for work with AI Google Cloud, but
yes.
you also use Azure or provisioning the Google Cloud infrastructure. Why you select Azure for clients, not do all on the Google?
Okay, interesting question. Firstly, Azure was our repo with data. And it helped us to automate everything. Of course, as an alternative, we can use, for example, GitHub, store our repo here and connect with the CI/CD pipeline to GCP. So I think it's more on your side, like what you're using in your project, what you're using in the team, etc.
I understand. Okay, so it's possible to have repo in GitHub or GitLab and use the CI/CD for run the process. Good. And as I understand, Vertex AI, it's something similar to AWS SageMaker. So it's correct?
Yes.
Good. Yeah.
The functionality is not like one-to-one with the same services, with the same functions, but similar.
Yeah. Okay, maybe someone on the Zoom have some questions. Why I see this one? Okay. Any questions? This one, we don't have the questions. In Zoom also.
By the way, I also think that GCP is a little bit new platform comparing to AWS in case of these ML services. So maybe if you ask someone maybe 1-2 years ago, they will say that I don't know, I know nothing about GCP ML services, and now it's different.
Yeah, for now, I think Google tried to play in this game and also provide different services, different solutions. And it's very good when you can select and see and have, for example, not many companies, but some of companies use Google, and to have this functionality into Google, it's very good. Because I think the driver of the industry still on AWS side.
Maybe like we are not comparing because it's difficult for me to answer.
Okay, if we don't have any questions, I want to say that don't forget to donate. We still help call or raise more money for help Ukraine army to buy high-end equipment for them. So please use the link under our video and donate to the Cola Fund. I want to say very big thanks for participation to Alena for this good and I would say for all who was with us today. We will see you on the next webinars. So we will write you when we will have the next webinar, and in near future we will publish all the videos from all previous webinars. So we will email you all about this also. So thank you for all, and see you on the next webinars, and happy Christmas, which will come, and happy New Year.
Thank you, Dimas. Thank you, Data Phoenix. See you. Bye.